Hello and welcome to yet another video. In this video, we will find solution to n-queen problem manually. Well, if you have watched my earlier video where I discussed n-queen problem and discussed an algorithm to solve it with a brute force method, in this one, we will solve it manually. Well, in that video, I also mentioned that finding solutions to n-queen problem manually is quite difficult. While making that video, I made some observations, and we will be using those observations here in this video, and those will make it slightly easier to find a solution manually. So, well, let's get started with it. Now, in this video, we will solve or we will find a solution for 8 queen problem. So n is 8 here. And the first thing that you should do is create a 3 by n table. So in this case, we'll create a 3 by 8 table. Okay, so let me draw that table first. Okay, we have our table ready. The first row in the table denotes x comma y, the coordinates where each queen should be placed. The second row is x plus y, the sum of the coordinates, and the third row is x minus y, the difference between the coordinates. Now to understand the coordinate part, let me draw the chessboard again with the row and column numbers. Okay, our chessboard is ready, and these are all the x values. These are all the y values. Just for clarity, write the coordinates for some of these squares. So this square is 0, 0, this square is 0, 7, this one is 7, 0, and this is 7, 7. Okay, so we know now how to identify each square on the board. And now let's try to fill in the table that we have created. And we have to fill this table with certain criteria. And those criteria are, first one is that x values must be unique. The second one is y values must be unique. The third is that x plus y, the sum of the coordinates, must be unique. And x minus y, the difference in the coordinate, must be unique. Now, okay, knowing the criteria, let's try to fill in the table. And we know that because these values, because the x values must be unique, we will have 0 to 7 values. So let me just already put those here. Now for the y values, let me make a list of values which I can easily choose from. This would make it easy to identify which values are used, which are not, and then we can easily choose the unique values for y. Okay, let's start with 0, 1. And that means the sum will be 1 and the difference will be minus 1. Okay, for y, I cannot use 0 because if I use 0, this sum will be 1 and 1 is already used. So let's remove that. I can't use 1 as well because 1 is already used here. So I will not be using 1. And if I use 2, there is still a problem because the difference will be minus 1 and minus 1 we already have. So I can't use 0, 1, 2 and I have to use 3 here. That makes the sum 4 and the difference minus 2. Similarly, I can't use 4 here because the difference will be minus 2. So I will use 5. Sum is 7, difference is minus 3. Same, I can't use 6 here, but I'll have to use 7. The sum will be 10, the difference will be minus 4. Now for 4, let's see which values I can use. I can't use 0 because then the sum will be 4. Can I use 1? Oh, I can't use 1 here because 1 is already used. So I will use 2. The sum is 6, the difference is 2. Then, okay, which values are used, which are not? One is already used, 2 is used, 3 is used, 4 is not, 5 is used, 7 is also used. So we have 0, 4, and 6. So let's use 0 here. Sum will be 5, difference will be 5, and let's use, well, let's use 4 here and see what happens. The sum becomes 10, so we can't use that because 10 is already present. Can't use 4, let's use 6. That makes the sum 12 and the difference 0. And then the remaining 4 I can use here. The sum is 11 and the difference is 3. Well, we know that all x values are unique. The y values are also, we have ensured to be unique. X plus y, 1, 4, 7, 10, 6, 5, 12, 11, they are all unique. X minus y, the difference is minus 1, minus 2, minus 3, minus 4, 2, 5, 0, 3. So yes, the differences are also unique. So, well, all our criteria are met. So this must be a solution. Let's verify that. First queen is present at 0, 1. So this is where we have a queen. 1, 3. Then we have 2, 5, 3, 7, 4, 2, 5, 0, 6, 6, and 7, 4. See, for the first one, the row seems to be safe. Column is also safe. The diagonals, this one is safe. This is also safe. Okay, for the second queen, the row is safe. The column is safe. The diagonals are safe. The next one, row is safe. Column is safe. The diagonals are also safe. For the fourth one, row is safe. Column is safe. Diagonals are also safe. Fifth one, row is safe, column is safe, diagonals are safe. Sixth one, row is safe, column is safe, diagonals are also safe. Seventh one, row, column, diagonals all safe. For the eighth one, row, column, and the diagonals are also safe. So there you have it. We have solved the 8 queen problem manually. So you might wonder, why do we have to use the brute force mechanism or an algorithm or a program to solve 8 queen problem or n queen problem if we can solve it manually this easy? Well, two things. One is that as the value of n increases, even the manual method becomes more and more difficult. And secondly, this method only gives you one solution. In order to find all the solutions, we have to try all possibilities, which is again not something we can manually do. So we have to use any algorithm or program to solve it. But this was a fun little exercise to do based on the observations that I had during my first video. If you like the content, hit like. For more such content, consider subscribing. If you have questions, put them in the comments. And thanks for watching. I'll see you in the next video.